Hello everyone, this is Mr. Slomkin, and today I wanted to talk to you about section 10.7, which is writing and graphing equations for circles. So we've been spending quite a bit of time with circles in chapter 10, and this is going to be kind of the final conclusion. And what we're going to do is we're going to do a bit of a very algebra thing. And the thing that we're going to do is we're going to graph these circles on an XY axis like all the graphs that you made back when you were in Algebra 1. So now let's start off with the equation. So the equation that I'm going to ask you to use when you're drawing your graph, or I'm going to ask you to write down if I were to give you a graph, is going to be this equation right here. This is a very unique equation compared to the things that you did see in algebra, and one of the reasons why I want you to notice is that it has the x variable and the y variable together on one side. So let's take a look at it. Specifically, it's x minus h squared plus y minus k squared, and it's going to be equal to one very lonely constant right over here, which is r squared. The h, the k, and the r will all be constants, which means they get replaced with numbers. The x and the y are going to be the variables, and they're just going to always stay x and y. The powers of 2 will always stay powers of 2. So let's break down a little bit more about those constants that we saw here, the h, the k, and the r. So the h and k, the ones that are paired with the x and y, are going to actually represent the location of the center point for your circle, which is one of the major critical parts of a circle. So the h represents the x value for the center, and the k represents the y value. Now, something I'd like you to try to remember about both of these guys, and this is something that I tell my algebra kids all the time, is that these two numbers are going to be liars. So do you see that little negative sign right there in front of the h, and the other negative sign that's in front of the k? Those negative signs mean that when you see the numbers that are inside the parentheses, they're going to be doing the exact opposite of what you think that they're going to be doing. So you're going to need to write them differently. Notice how this h has a negative, but this one does not. Notice how this k has a negative, but this one does not. That's critical. The other critical thing to note is that the r right over here, I'm sure that you've already guessed that r stands for radius, which is great. But I also want you to notice that in this equation, it is not r by itself, but rather r squared. So you need to watch out for these little tiny tips and tricks, otherwise you might get burned. Next, an important thing to also remember, and this is definitely a review topic, is the distance formula. This has popped up very often in the recent past, and that's just because it's a really useful tool, and so I just wanted to remind you of the distance formula in case you need to use it. So let's see if we can dive into a couple of example problems. I'll do one, you'll do one, I'll do one, you'll do one. So let's start off right here. So to begin with, what we're going to do is we're going to start very simply with a graph, and what I'm going to ask you to do is I'm going to ask you to write out the equation. And this is going to require very little work. It's going to go very smoothly. Here's what you really need to do. Thing number one is you need to find out where the center is for your graph and what the radius is. Then after that, thing number two is going to be to plug them into the formula, and that's pretty much it. So let's see if we can identify that information. Just by looking at the picture, even though it's not very clearly labeled, I can tell that the center point belongs right there. It is equidistant from all of the different curved edges of the circle, and so that is going to be my center point. It exists at 0, 0. Now the great thing about that center point is that that is going to represent both your h value and your k value. So that's going to take care of two of the numbers that you're supposed to fill in. The third number that we need is the r value, or the radius. Now the radius can be found on our drawing very quickly and easily in a lot of different places. You could count from the center to the right, or you could count to the left, you could count up, or you could count down. No matter which direction you count, what you're going to notice is we are always counting 2 units because the radius is 2. Okay, let's write down our perfect final answer. So when we're writing down our perfect final answer, you want to start off with your x's and your y's. I like to build a little bit of a skeleton first. Then after that, what I'm going to do is I'm going to fill in a couple of extra pieces. So what I'm going to do is I'm going to plug in my h and my k values. H is for x, so it gets grouped in here with the x. K is for y, so it gets grouped in here with the y. Now remember that both of these need to be liars, so I'm going to write it as minus for both of those. And then lastly, the r value goes at the very back, but also remember the trick about that one is that it is squared. Now this looks pretty good, but it's not perfect. Let's make it look all nice and spiffy. So right here, what happens when you subtract 0? Absolutely nothing. So a much simpler way to write that would be this. Same thing here. And then lastly, this is the most critical part right here. You can't leave it as 2 squared. You've got to actually square it. 2 squared is 4. This is your best answer right here for the equation of the circle that is drawn for you. Do you see how simple and straightforward it is? It works really, really nicely. Okay, your turn. See if you can try letter B on your own. Pause the video now, and I'll put the answer up when you're done. Here's the answer to letter B right here. It also has a center at 0, 0, which is going to represent your h and k value. It has a radius of 6 units. Watch out for the scale factor on here. And then, when you square those guys right there, you need to watch out, and you're going to end up with a 36 at the end of your equation. Let's do the same kind of work. Let's write another equation, but this time I'm not going to give you a nice clear picture. I'm rather just going to list the information for you in a sentence. This is not as easy, but it is still pretty straightforward. It says write the standard form equation of a circle with a center and a radius. So once again, they're pretty much giving you everything that you need. And now it's all just listed for you, so you don't have to hunt for it in the picture. So remember, center is great because it's going to give you both the h value and it's also going to give you the k value. The radius right here is going to be a 3.7, which is a decimal this time, but that's okay. Let's see if we can start writing our equation. So remember, what I like to set up my little skeleton. So I'm going to have my parentheses for my x and another set of parentheses for my y. Then I like to put in my h and my k values. And remember that they need to be liars. So my 0 can be minus. My 5 was negative, and so when I put that guy in there, I'm going to write it in as a positive. And then lastly, my radius. My radius right here needs to go in, but it also needs to get squared. Okay, perfect final answer. Perfect final answer means that we're going to do a little bit of simplifying over here on the left. X minus 0 is just x, so we're going to write that one nicer. Y plus 5 cannot be made any nicer, so we're going to leave that one as y plus 5. And then lastly, 3.7 squared. You do need to square it. I'm requiring you to square it each time. This one's not going to square very nicely, and so we're going to round 2 digits just like we always do. That's going to be 13.69. There's our perfect equation this time right here. Okay, your turn. The next one right here is for you. It has its own center point and its own radius, and I want you to find those for me now. Pause the video, and then I'll share the answer with you in a couple seconds. Here's the answer for your second you try problem. We have our center point of 3 and 5 going in. I want you to notice that the signs in the equation are the exact opposite of the information that was originally given to you. I also want you to notice that the radius is being squared, so our 6.1 doesn't last for long, and it becomes 37.21. Here's our final equation right here, and it looks great. Okay. Let's bump up the complexity a little bit more. So now, for this next one, I want you to notice that they are changing some of the information that they're giving to you. So it says the point negative 3, 4 is on a circle. So this is not a particularly special point, and it's not very helpful for our equation. It's just some point. You can see that here. It's kind of over here in the upper left-hand area of the circle. It doesn't have any specific significance. Now, this second thing they give us is a circle with a center at negative 1, 2. That is important. That's the center point, and so that is going to be able to give us our h value and our k value. Now, they do not mention anything about the radius at all. They just say write the standard form equation. So one of the things that's going to be different about this problem compared to the last couple is that you actually need to find something. You're going to need to find the radius. Now, the radius is usually found by, once again, counting to the right or to the left or up or down. But what I notice is when I count to the right, it looks like it's almost 3, but it also looks like it's a little bit short. So counting or estimating is a poor idea. We're not going to do that. Instead, what we're going to do is we're going to also realize that instead of just counting to the right or to the left or up or down, you could also count from the center to this point that they had mentioned earlier. That would also give us the radius. Instead of counting on the graph, though, we're going to use the distance formula. So let's use the distance formula to find the distance between these two pieces, and that distance will be our radius. When you're setting up the distance formula, you're going to start with your x values. You can do negative 3 minus a negative 1, or you can do negative 1 minus a negative 3. I'm going to choose to go from the negative 1, and then I'm going to subtract the negative 3. I'm going to do the 2, and I'm going to subtract 4. Minus a negative is going to be a positive, so we're going to end up with 2 there. Right over here, 2 minus 4 is going to be negative, so we're going to end up with a negative 2. We're going to square both of these, and even though one is positive and one is negative, it doesn't matter. 2 squared is 4, and negative 2 squared is also 4. Our square root is going to be 8. Now, if you're already panicking and you're saying to yourself, oh man, I already know that the square root of 8 is not great. I agree. But here's what I want you to do. I want you to just hang out for a couple seconds, and I don't want you to write down any decimals. So we are going to leave it just like that. Don't type it into your calculator. Just leave it as the square root of 8, and I'll show you exactly why in a couple of seconds. I'll be honest with you, even if I knew that it was going to turn out nicely, I would still leave it under the square root, and I'll show you why. This value that we have right here is going to be our radius. So now what we've done is we've collected our h and our k, which we had right off the bat, and now we have our radius as well, which means we have everything we need to write our equation. So let's see if we can do that. Our equation is going to start off with our small skeleton. Here we go. Now I'm going to plug in my h and my k values. Remember, they need to be liars. So when I plug in the 1 and the 2, the 1 was negative, and now it's going to be positive. The 2 was positive, and now it's going to be negative. Then I'm going to plug in my radius, and the important thing to remember about the radius is that it is always going to be squared. Okay, let's simplify. X plus 1 cannot be simplified at all, so we're going to leave it as x plus 1 squared. Y minus 2 cannot be simplified at all, so we will leave it as y minus 2 squared. And now here's the fun part. Do you know what happens when you have a square root and a power of 2 at the same time? The thing that happens here is that they cancel each other out, and you are left with 8. So that is a really, really great trick right there. So that is exactly why I leave it as a square root, because I know that in a couple of steps the square root will disappear. I won't have to worry about decimals at all. I won't have to round or panic in any way. It will all turn out clean in the end. And so that one looks perfect. Okay, next one is yours. I want you to try this problem right here on your own and see if you can get the correct answer. I want you to pause the video, and then I'll share the answer with you in a couple of moments. Here's your final answer. Once again, this point is not particularly important, but this center point is. So we are going to use that center point quite a bit. But this point will help us find the radius. It doesn't represent the radius, but it will help us find the radius using the distance formula. So we start off by using both of these points right here. We're going to calculate our radius, which is going to be the square root of 41. Once again, not a very nice number to take the square root of. Luckily, we don't have to. We're going to leave it as the square root of 41. Then we're going to pair it up with our center point. We're going to use our information about our liars and our square root right here. And when it's all said and done, the square root and the power of 2 cancel each other out, and we're left with just a 41, which is fantastic. So there is your second problem right there. Okay, last one. Last topic that I want to talk to you about is actually graphing them. And I think that we've saved the best part for last. So graphing these, I think, is a lot of fun. There's a little bit of strategy that I think that you're going to want to make sure you know before you attempt one on your own, but I'll happily show that to you right now. So let's go through this guy. Here, this time I'm going to give you the equation, and I'm going to ask you to draw the graph. So right off the bat, one of the first things you're going to want to do is you're going to want to locate the center. And you can find that very quickly and easily because you are given the h and the k values. Remember that these guys are liars. So you're going to want to make sure that you are using the opposite. So this negative 2 is actually a positive 2, and that positive 3 is actually a negative 3. You can write down where your center point is, and you can also graph it. Now be careful here on your xy axis. I want you to notice that sometimes your factor is not always y1. So this graph is counting by 2's on both the x-axis and y-axis. So when you're going 2 units over, that's not 2 tick marks over, that's rather just 1 tick mark over. And when you're going down 3 units, that's going to actually be between 2 tick marks. So we are going to have our spot right there. That's our center. Okay, now here's the really important part, the radius. So the radius is going to come from the 16, but it isn't actually 16. Remember that that 16 represents radius squared. So we are going to need to remember that when we're working with the 16. We need to, this time, take the square root in order to shrink this down to the appropriate radius. The radius for this problem is 4, not 16, which is a big, big difference. Okay, now I need to get this radius of 4 onto my drawing, and so I'm going to do this in a couple of different ways. One way I'm going to do it is I'm going to start here from the center, not from the origin, but from the center. I'm going to start from the center, and I'm going to count 4 units to the right. I'm also going to count 4 units to the left. I'm going to count 4 units up, and I'm going to count 4 units down. So that's, once again, counting by 2's. So that's 2, 4. There we go. I'm going to count to the left. 2, 4. I'm going to count up. 1, 2, 3, 4. And I'm going to count down. 1, 2, 3, 4. Now these 4 points are going to lie on the outer rim or the circumference of our circle right here. And so to draw your perfect graph, all you need to do is, as best as you can, draw a nice round circle that connects the 4 points together. This is always fun because it is a bit more challenging than what you might think. And a lot of times most students end up by drawing some sort of diamond for their first couple of attempts. There's my best circle. It's not perfect, but it's not terrible. All right, your turn. This is our last problem together. I want you to try out this one. Once again, pause the video and then I'll share the final answer with you. Center is going to be at -2, 1. That's the exact opposite of the numbers that were given. And the radius is not 9, but rather the square root of 9. So we're going to be counting 3 units. I'm going to start by graphing my center. This time the scale is 1, so I go 2 units over and 1 unit up. And then I'm going to be counting 3 units to the right, 3 units to the left, 3 units up, and 3 units down. Then you can connect everything with a nice smooth curve that goes all the way around. These 4 points that go around the top and bottom and left and right of the center are sometimes referred to as the critical points. And if you take a pre-calculus class, they're going to want you to tell them exactly where they're located. But for right now, I'm just happy to have you graph them. Okay, give the worksheets a try, give the check a try, and see if we can finish off Chapter 10 together. Thank you so much.